So the next section of our textbook deals with investments, things such as annuities, Roth IRA, savings. And if you'd like detailed information, I'd encourage you to read this section of our textbook. It has a lot of various pieces of information. We're going to take a kind of overall approach. We're not going to get into any specific calculations in this section. We've actually already covered the calculations relevant to this kind of growth, that's compound interest, which we did in our last video. Here we want to take more of a macro view and just see the amazing growth of compound interest over large values in a significant amount of time. And a great example of that is the Roth IRA. So the acronym IRA stands for Individual Retirement Account. It's a retirement account that contributions are made with after-tax dollars, but withdrawals are tax-free. That's one thing that makes this account particularly attractive. The government does limit the amount of money you can invest in an IRA each year. So even if you had tons of money, you couldn't just put that into a Roth IRA in 1 year. You're limited by the cap. So for 2024, it's $7,000 annually for an individual under 50. 50 and over, it's $8,000 annually with the $1,000 catch-up contribution. There are income limits on the Roth IRA, so you can only utilize the Roth IRA up to a certain income level that you could look up if you're interested. And the magic of Roth IRAs, apart from the tax-free growth, is the compound interest over time. So let's look at our example here. If we take the annual limit for 2024 of $7,000, that's about $135 weekly. Suppose we invest that in an S&P index fund. What I have highlighted here is historically the S&P annual average return is about 7%. So $135 a week contributed for 30 years, we've put in $210 cash total. Let's see how much the growth over time contributed to. If we contributed this every year, $135 a week for 30 years, then the total value in the account, assuming 7% growth, is $490,000. If we waited an additional 10 years and we kept contributing $135 weekly and getting compound growth of 7%, then the overall value in the account would be a staggering $884,000. So remember, for the 30-year period, we only inputted $210,000 in cash. We would have contributed more for the 40-year period. You can make that calculation on your own if you like, 7,000 times 40. But in both cases, we've gained more than the amount that we put in interest over time. So all of this growth can now be taken out due to the tax advantage nature of the IRA as tax-free gains. And the reason it grows so significantly is we get interest, our contributions, and reinvested earnings, which allows it to grow through compound interest. Now on this next page, I have a table showing the growth over time. So in year one, we input $7,000. And then in year two, we add another $7,000. Remember, we pay $7,000 into the account each year. So at this point, we've contributed $14,000 by year two, and we earned about $420 in interest. Now this is just an example. In actuality, if you invest in the S&P 500, you are not guaranteed 7% interest each year. Where the 7% comes from is it's taken the historical average of the S&P and says, while some years are more, less, some gain, some lose, on average it is 7% growth. So because we want to deal with this mathematical example and make things simpler, we're assuming 7% growth, but that is not guaranteed. So then what happens the next year is we take this 14 for 20 and we add another $7,000, and this is our account balance. So each year we max out the contribution. Now the interest, instead of $420, since we have a larger account balance, 7% of that is $822. So that $822 gets added to this, plus we add in another $7,000, and that's where we get this $30,486.37 as our new account balance. We then gain this much in interest, add another $7,000, and it just keeps going down the list. So let's see how our account balance goes over time. Again, we're not doing the math here. Our real focus is seeing how the growth changes over time. We started at 7,000, then to 14,000, 22,000, 30,000, 39,000, 48,000. Keep in mind we're only contributing 7,000 each year. Everything else is growth. 57,000, 60,000, 78,000. After 10 years, we're at 90,000. Keep in mind, after 10 years, if you did 7,000 a year, we've only put in 70,000 in cash by year 10, but it's now 90,000. We've experienced 20,000 of growth if we get the expected interest of 7%. Let's see how the growth continues. After 20 years, so let's see, what is 20 times 7,000? So 20 years of contributing 7,000 a year, we've used 140,000 in cash, but our value is now 240,819. So our growth from interest at year 20 is 100,000 that we've gained from interest. If we continue investing 77,000 a year, keeping in our account balance growing over time, by year 30, we get to this balance. If we keep it up another 10 more years, we'd end at year 40 with $884,268.18. And in that last year, the amount of interest that we'd gain on the account is $17,000. So you can see at the end of the investment cycle, when the principal is so large, the amount gained by interest each year gets larger and larger and larger as well. And excuse me, I just saw here, this was a 6% growth rate. So the goal of this assignment was more to show how it grows over time. And I know this topic can seem a little dry, but the importance of compound interest and how it can grow the amount that you invest is a very useful topic. So if you're interested, I'd encourage you to read further in the textbook or other trusted sources that you have. So there's no calculations from this section. For our quiz, the key thing to keep in mind is the information provided here. So don't be worried about the quiz. You only type in the answers that we discussed through this example. So go to the quiz. No calculations needed, just respond based on what you found here. If you have any questions, let me know and I'll be happy to help.